in this video I'd like to talk about a very important physics concept here, and it's called friction. Friction. Friction is essentially a force that opposes motion. But we'll learn that this is not all of friction. Friction is actually much more than just something that is opposing motion. That opposes motion. Friction is basically, if I have an inclined plane here, and I have a mass sitting on top of this inclined plane, friction is essentially the reason why, if I basically, let's finish this inclined plane to look like a triangle. Essentially, what we're looking at when we talk about friction is, as we increase this angle here is going to be called theta. As we increase theta, as we increase theta, so now theta is not just like that, that's that angle there, now that's much larger, and then eventually it's going to become all the way here. As we increase this angle, you will see this box begin to essentially slide. So at this angle is going to be sliding, it's going to be sliding just a little bit, and at this angle it's essentially going to just be it's going to be sliding a whole lot, even very, very fast. Friction is essentially the reason why we have to change angles in order to get this object to move, because friction is the attraction between two masses. Friction is the force generated by two masses that essentially touch, so essentially are together. So if we look at friction, we see that there are two things that's going on here. We see that there are two types of friction. There are actually two types of friction. We have static friction and we have kinetic friction. Static friction is basically what's keeping you from moving in the first place. So if we have our object again sitting on this inclined plane, static friction is what's preventing this object from moving down in the first place. However, kinetic friction is what's slowing it down as it's moving. So static prevents it from moving in the first place. Kinetic friction is when it's essentially starting again, when it's already sliding. Kinetic friction basically tries to slow it down. Now, if we take a look at, let's take a look at the coefficient of friction. Friction has the coefficient, it shares its coefficient with essentially the symbol for micro. This is mu, it's pronounced mu or mu. I've heard it pronounced both ways. And essentially it is the coefficient of friction. Likewise, if we take mu and we add a subscript to it, we can change it to specify whether it's either static friction or kinetic friction. So we have mu s and we have mu k. Now if we go back and review back to different forces, we learned about normal force. And we learned that if normal force basically is the force that's opposing gravity. If we have an object here sitting on a table, then there's the force of gravity acting downward, but then the equal and opposite force to gravity is normal force. So normal force essentially the equal and opposite force is basically the opposite force to gravity. Now that becomes a little trickier when you talk about inclined planes because gravity acts straight down. However, normal force is always perpendicular to the surface. So normal force is always perpendicular, but gravity always acts downward. So we're talking about normal force, essentially the reason why we don't crash through tables or the floor. So the reason I bring that up is because the formula for the force of friction, so mu sub F times the normal force, is essentially the force of friction. So the force of friction is the mu of F. That's the coefficient of friction times normal force. Now, if we wanted to calculate the force of the kinetic friction, then we would take the constant, the kinetic friction constant, multiply that by normal force, and we would get F sub k. Likewise, if we multiplied mu s times n, then we would get F sub s. So what are these coefficients? What does this mu mean? In every physics problem, they're going to essentially specify what mu is. Basically, it's the frictional constant. For example, ice. If we look at ice, the frictional constant is going to be lower. The coefficient is going to be lower than for example, if we were to look at carpet. If we were to look at carpet, and this is like the very rough brand of carpet, this might be a high coefficient. Usually they range between 0.0 and 1.0. There are some that are very high, but this is usually the general range for them. So friction is very important because it's unless something says it's a frictional surface, we have to always assume that there is friction. An example problem using friction is if we have, for example, a chain of boxes. We have a chain of boxes. And they are all linked together. And we are essentially pulling them. This one here, this is 5 kilograms. This is 3 kilograms. This is 1 kilogram. Then this whole thing is moving to the right with a force of basically with a velocity of 3 meters per second, and we need to find how fast each one of these are going. Well, this problem is essentially saying that we need to find we know that F is equal to ma. We know that it's moving at it's basically the whole thing is moving at 3 meters per second. So if we look at the total mass, we know that so essentially that's how we would solve this problem, by calculating the total mass. Then we calculate how much force is on this section of the rope and how much is on this section. We'll be able to figure out how much the tension on the rope is. But if we add friction into it, I'm not actually going to solve this problem here, we'll have to save that for a later video. But if we add friction to it, then we'd have to subtract the force of friction. So as you can see, that will make a big impact on our answer. So that we will solve that problem in a later video. However, that's just to show how important the ability to calculate friction is. So remember that it is opposing motion. However, when we looked at static friction, here, if I say that friction is the force that opposing motion, that's actually not 100% true. If we look at kinetic friction, opposes motion. However, static friction the force that's preventing it, the friction that's preventing the object from moving in the first place, is going to need a force opposes a force. So if we have an object and there's a force acting this way, the static friction, that's force applied, the force of the static friction is going to be this way. However, if the object is moving this way with x meters per second, then the kinetic friction is going to be acting this way. The friction F of k is going to be this way, but there's no F of k at this point is equal to 0, and if we look here, the kinetic friction is essentially 0, and if we look here, the static friction is 0. So that's very important to know how to calculate friction.